Sample problem 19.1. Permanganate ion and iodide ion react in basic solution to produce manganese 4 oxide and molecular iodine. Use the half reaction method to balance the equation. Okay, so we're going to use the half reaction method. This is in basic solution, so there is an additional step at the end. So I'll identify it when we get to that point. So the first step, when you balance these half reactions, when you balance these redox reactions, you separate the equation into two half reactions, and then you balance each one of them. So what I'm going to do is I'm going to take the first half reaction, and I'm going to balance that first, then I'll go back to the overall equation, and then balance the second half reaction. Now, I picked manganese. It's MnO4 minus on the reactant side and MnO2 on the product side. So I'm balancing, really what I'm doing is balancing manganese, but in the process we'll also balance oxygen. Okay? So first step, how many manganese are on each side? You balance that first. There is one manganese on both sides, each side. So that means that manganese is balanced. Next, we balance oxygen. There are 4 oxygens on the reactant side, 4, but only 2 on the product side. So we add water to the side that has fewer oxygens. Not oxygen, we add water. This is a reaction that is occurring in water. It's an aqueous solution. So for that reason, we're going to use water. So 2 waters will balance the oxygens. Then, excuse me, then we balance the hydrogens. And there are 4 hydrogens on the product side. So we need 4 hydrogens on the reactant side. Okay? Again, we're going to use hydrogen ions. This is in water. The hydrogen ion dissolves in water. H2, which you might think of using, won't work because it does not dissolve into water. Okay? So 4H plus, MnO4 minus. The last step in balancing this half reaction is to add electrons to the more positive side. Now, the products don't have any charges. They're both 0. So it's 0 on the product side. But on the reactant side, we have 2 charges here. We have the plus 4 and the minus 1. Now, why plus 4? Why not plus 1? There's 4 hydrogens, not just 1 hydrogen. There's 4 of them, so that's plus 4. And then there's 1 MnO4 minus, that's 1 negative. So overall, if you take plus 4 and minus 1, you get plus 3. So you just add 3 electrons because electrons are negative. This is a redox reaction, so we're claiming that electrons are transferred in this reaction. Okay, charge is balanced, manganese is balanced, oxygen is balanced. Next step, do the second half reaction. Iodide ion, that's called iodide, is turned into iodine. Iodine is the element, iodide is the ion. There are 2 on the product side, but only 1 on the reactant side, so we put a 2. Then there's nothing else to balance. There's no oxygen or hydrogen. So now we just do the charge. There's 2 negatives on the reactant side, no negatives on the product side, so the product side's more positive. So we add 2 electrons over here. And now we've balanced the half reaction. So we have 2 balanced half reactions. Now you equalize the electrons in the half reactions. So we need a lowest common factor between 3 and 2. That's 6. So that means we're going to have 6 electrons in both equations. So for the half reaction, the way we would deal with that is to multiply it by 2. 2 times 3 is 6. So I'm just going to write it this way. And then for the other half reaction, we're going to multiply it by 3. Okay, 6 electrons are equal. So now I'm going to go ahead and multiply it 3. We got, for the first half reaction, we got 6 electrons. 2 times 4 is 8 hydrogen ions. 2 times 1 is 2. Gives us 2 MnO2 plus 4 waters. So that's done. Now we do the second half reaction, the iodide. 6 iodides goes to 3 iodines plus 6 electrons. See how the electrons are equal? Cancel them. Is there anything else we can cancel? There's nothing else we can cancel. So that's overall. We add them, re-add them. So it's going to be a lot of room, a lot of material here. So I'm going to write it a little bit smaller. 8 hydrogen ions plus, this is a negative by the way, 2 permanganates plus 6 iodides. So those are the reactants. And then on the product side, you got 2 manganese dioxides, 4 waters, and 3 iodines. Okay, everything's balanced. You could add up all the charges and everything. There's a total of 8 negatives on the reactant side plus 8 positives. No charges on the product side. If this were acidic solution, we'd be done. But it's not. It says in the problem that this is in basic solution. So we have one more step to do. And here's what you do. You add to both sides the same number of hydroxides as you have hydrogen ions. So you see how you have 8H plus? You add 8 hydroxides to both sides. Because it says it's in basic solution. Basic means you've got hydroxide. Now what's interesting about doing it this way, I'm going to draw a line here so you can see, is that if you take 8H plus and 8OH minus, that's 8 waters, right? H plus plus OH minus is waters, so that's really 8 waters. Right? If you add 8H plus to this, 8OH minus to this side, it'll react with the H plus. That's sort of the logic behind it. And then you've got 6 iodides. Goes to 2 manganese dioxides plus 4 waters. 3 iodides, let's see, iodines. 8 hydroxides. Now, if you note, there's water on both sides, so we're going to cancel the waters. So now you got 4 waters, 2 permanganates, 6 iodides, 2 manganese dioxides, 3 iodines, 8 hydroxides. And there you go. Everything's balanced. And it's in basic solution because of the hydroxide. And there you go. Again, if it had been in acidic solution, we would have stopped before we add the hydroxides.